I'm Mr. McBrien. This is TEJ20, Mathematics and Engineering. Today we're going to talk about the importance of mathematics. We're going to talk about power in a circuit. We're going to talk about how to report calculations in TEJ20 and how to maximize your marks across every STEM course you ever take, right through post-secondary education. So first off, let's talk about why mathematics. Well, the answer is that more than anything else, mathematics is the language of science and engineering. Forget about Latin, forget about English. Mathematics is how we describe scientific concepts. It's worth noting that with very few exceptions, all of our observations in science are in number form. And generally, we consider a concept understood when we can make predictions about numbers and then confirm them with experimental data. So we need to be able to communicate mathematically. We need to be able to do effective calculations. We need to be able to read questions. We need to be able to communicate calculations to colleagues, to teachers. So we need, of course, a structure for showing those calculations. We're going to use power in a circuit as that approach. You may remember it from science class. But if you don't remember that power is the energy consumed per unit time, or the power generated per unit time, it's okay. We can cover that quickly right now. So the power, represented by a capital P, is consumed by a circuit, and it's proportional to the current and the potential. So the equation looks like this. P equals I, the current, times the potential, V. We'll use this power equation as our target example for the guess process that we're going to show now. So you may have already figured out that guess is an acronym. It stands for the steps of communicating a solution in mathematics. We're going to use this simple reporting system, and it's going to give us at least 3 benefits. One, it's going to help us with our thought processes. It's going to help us to think through questions effectively. The next is near and dear to my heart. It's going to make marking easier for people reviewing our solutions. And again, a benefit to you, it's going to give you increased chances for part marks in the unlikely scenario that you'll report an incorrect answer. So the guess reporting system can improve your marks across math, science, and engineering classes. So what is it exactly? Well, the G stands for givens. The U stands for the thing we're supposed to find. E stands for the equation we're going to use to find it. S is substituting in the givens. The second S is calculating the unknown. Okay, let's go through all of these in order. So the givens, all we have to do is write the values that were provided in the question itself. We need to be able to assign the correct letters to those things. Writing these down may seem like a waste of time. It's not. It helps you form your thoughts, and it helps you identify the equation that you're going to use to do your calculation. So we're going to use this circuit example on the right-hand side as our illustration of the guess process. So our question associated with this circuit might be, what's the power consumption in a circuit that has a current of 0.003 amps at a potential of 9 volts? And our first step then is to identify the givens. We've got to know that current is I. So I equals 0.003 amps. We've got to know that the symbol for potential is V. And once we do that, V equals 9 volts. We've now completed the G in our guess process. Now the unknown, we have to identify this from the question. It'll be usually right after the phrase "what is" or "calculate the." So the unknown is what the question asked us to solve. All we have to do is read the question, assign a letter to it, and record it, just like this. So if the question had asked us for potential, it would be V equals question mark. If you successfully record the givens and the unknowns, you get a half mark before you even start to calculate the answer to the question. So in this case, our unknown is the power consumption, and P stands for power, so we would write P equals question mark. Next is the E in guess equation. We just write the equation we're going to use. The good news is it's really easy to figure out that equation because we've written the givens and the unknowns. All we have to do is find an equation that has all those letters in it. So writing the equation, though, helps you identify when that equation's in the right form. We'll talk more about that in a second. It avoids transcription errors. You avoid the errors where you just quickly write it down and you write it slightly incorrectly. It's easy to check over your work. And guess what? Correctly writing the equation gets you a mark. So in this case, our E, the equation, P equals IV. And before we proceed to the substitution step, we make sure the equation's in the right form. We make sure that the unknown is alone. And in that case it was. It was alone and on the left-hand side, P equals IV. So whenever it isn't in the right form, we will apply algebra. So in this case, we're in the correct form. P is on its own. We can proceed to the substitution step. So S is for substitution. We simply substitute in from the givens into the equation. And amazingly, we get a half mark for this. If we can successfully substitute in, we get a half mark, even if we're wrong with the calculator after that step. So P equals IV. We know from our givens up above, I equals 0.003 amps. And V is equal to 9 volts. Yay, a half mark. So now it's time for the calculator. Now a quick note about this. If you don't have a calculator, it's now time to buy one. Okay? Use the calculator not just during tests. Use it for your homework. Why? Many students suffer from test anxiety. You want to practice how you play. So you're going to bring your calculator for quizzes and tests, but you're going to use it for your homework. Many students use their phones as a calculator when they're doing their homework because it's inconvenient to get out their calculator. This causes you lots and lots of extra stress during the test, and extra stress is not what you need. So practice how you play. Okay, so you get out your calculator, you type in 0.003 times 9, you get 0.027 watts. And you're done, right? Well, the answer is no, you're not finished. Okay, we've got to get rid of this habit of writing down an answer and quickly flipping to the next question. Before we proceed beyond this portion of our exam, this portion of our worksheet, we need to ask ourselves the two questions. The two questions are a tool to increase the probability that you're going to put the right answer on the page. By the way, these are used by scientists and engineers all the time to make sure that they don't kill people. Well, in our case, we're going to use them to increase the marks that we get in our courses. So what are the two questions? The first is, what are my units and do they match the question? Did I remember to write the units down? And do they match the units for the thing I've been asked for. And the second question is, does my answer make sense? In the physical world, does the number I've written down have any basis? You need to practice this technique, okay? If you only do this, if you decide you're only going to do this during tests, you will forget and you won't be good at it. So, you practice this technique when you're doing your homework so that you remember to do it during the test and so that you have it as a skill when you go to do that next quiz. So you need to practice this technique. As soon as you write the answer down, you ask yourself the two questions before you look at the answer key, before you flip to the back of the book, before you look at the solutions. And as a tip to help you remember, underline the answer after you've completed the two questions so that you know you've done it. It has a side benefit. It calls the attention of the marker to the thing you want them to mark. Okay, so in our case, the power equals 0.027 watts. Well, if we remember, the W after 0.027 stands for watts, and that is the units of power. So our units seem to be correct. That's good news. As to whether that number is reasonable, we don't know enough yet to have a feeling for that. As we complete more questions, do more worksheets, the side benefit to practicing there is we start to get an idea of what numbers are reasonable, which ones are not. So it's a small circuit, and we'll just have to accept that it's got a small number there and move on for now. Okay, let's do one more example. Voltage in a circuit. So a Tesla motor claims 325,000 watt output. The battery has a maximum current of 1500 amps. If we assume 100% efficiency, that is, all of the current goes towards the output, what's the voltage produced by the batteries? We got a little bit of extra data here, but we should still be able to do this. Our givens in this case. Our givens are a current of 1500 amps and a power of 325,000 watts. Our unknowns. The thing we're being asked for is the voltage or the potential. Well, the symbol for potential is V, so we write V equals question mark. Our equation needs to contain those three letters. Well, P equals IV. It also needs to be in the right form. Is it in the right form? Well, it's in the right form when V is on its own, right? Uh-oh, it's not. So, our equation's not in the right form and we have to stop and do one more step. What's that step? Well, it's algebra. We need to isolate the number we need. What does isolate mean? It means just get it on its own. So the number we need, that's straight out of our use step in guess. We know that V needs to be alone. So how do we get it alone? Well, the answer is we figure out what's wrong. So what is wrong here? V is multiplied by I. This is inconvenient, but not a huge problem. Anytime we identify that problem like that, we need to do the opposite. That's right. So to remove that I, we have to do the opposite. What's the opposite of multiplying by I? Dividing by I. So we're going to take IV and divide by I, because we know that's going to get V on its own. But anything we do to one side, we have to do to the other to keep it equal. So we also need to divide P by I. Now notice, the i's here are going to cancel. That's why we did it in the first place. I divided by I is 1, and those things go away. That's the whole point of what we're doing here. So, P over I equals IV over I. Cancel the i's. P over I is equal to V. And now we have the equation in the right form. We can move to the substitution step. Substitution step for P, the power, we substitute in 325,000 watts. The current I is 1500 amps. And then for the solution, we get out our calculator, and 325,000 divided by 1,500 is 220 volts. Are we done? No, absolutely not. We have to ask ourselves the two questions. So the first question, did I remember my units and are they correct? Well, we put V down there, and the units are supposed to be for voltage or potential are volts or V. So yes, we've got our units correct. Is 220 volts reasonable? Well, again, we haven't had much experience yet with circuits, but you might know that line voltage in a house is 120 volts, so it's not a crazy number. So we can go ahead and underline this and move on to the next question. Now, let's illustrate quickly the value of the two questions. So our units were correct, we could see. What if, here's our equation, 325,000 watts divided by 1,500 amps. What if we had multiplied? What if we'd hit the wrong key on the calculator? Or what if we'd done the algebra incorrectly? Just slipped up that one time. I know most of you students out there are perfect, but let's just, for sake of argument, say that you made a small mistake. Well, 325,000 watts times 1,500 amps is in fact, let's get this right, 487,500,000 volts, which is more potential than is in a lightning bolt, incidentally. But we don't know that yet because we haven't spent that much time with circuits. What we do know is that's a really big number. In science, there can be really big numbers, and we should recognize situations where there should be a big number. But this probably isn't one. A battery in a car that you can buy for less than $100,000 probably is not going to be producing such a crazy number of volts. The answer doesn't feel right. And when it doesn't feel right, we don't underline it immediately. Instead, we go and we check our algebra over. We check our substitution over and make sure everything is the way it should be. If we can't find the problem, well, we have to shrug and report it anyway. Maybe it is correct. But this is the perfect opportunity to know that we should check over our algebra. If you can start to catch some of these errors like this, you can start to decrease the number of marks that you lose on tests. Okay, let's move on then. So our key points. Math is the language of science and engineering. The power of a circuit is the amount of energy consumed or generated per unit time. And the equation for this is P equals IV. Guess is a system of reporting solutions to mathematical problems. It helps guide your thinking, it increases your marks, and it makes teachers happy, which is never a bad thing. The two questions will reduce the marks that you lose through your entire STEM career out through post-secondary education. For your homework, I'd like you to complete the Power in a Circuit worksheet. Be sure to use the guess system for each question. Remember, practice how you play. And ask yourself the two questions with each answer that you write down before you check the solutions. Did it help you get any answers correct that you might not have otherwise? Maybe not, but practice it regardless. Thanks very much. Have a great night.